Welcome back to my YouTube channel. Today's LeetCode DCC question is find the town judge. In a town, there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then it is mandatory that this three condition is satisfying. So what is the first condition? The first condition says the town judge trusts nobody. Second condition says everybody except for the town judge trusts the town judge. There is exactly one person that satisfies property 1 and property 2. So what question is saying, suppose in a town we have n peoples, and out of this n peoples there is exactly one judge if it exists. So what are the conditions that is satisfied if there exists a town judge? So suppose this person is a town judge. The town judge trusts nobody. Condition 1 says this if this is a town judge, then this person will not trust any of the remaining person. Condition 2 says everybody except for the town judge trusts the town judge. That means remaining person except the town judge, everyone trusts town judge. This person also trusts town judge. This person also trusts town judge. Like this, everyone except that person, except the town judge, trusts town judge. Third point is saying there is exactly one person that satisfies property 1 and 2. So let's see whether there can be more than one person or not. Suppose we have 5 person in the town, right? Now, if suppose we consider the first person as the judge, that means according to condition 1, this person will not trust any of the person, and according to condition 2, remaining person will trust the judge. That is, remaining person will trust the person 1, right? Till now we can say we there exists one town judge and everyone every all the two condition is satisfied, condition 1 and condition 2. Now suppose we say there is one more person as a town judge, right? So if this person is also a town judge, that means according to condition 1, the town judge trusts no, this person will also not trust any of the person, and according to condition 2, everybody except for the town judge trusts the town judge. That means if this person is a town judge, then remaining person must trust this person. But it is contradicting. Since we have seen this person 1 trusts nobody, person 1 trusts nobody, and we are saying if this person has to be town judge, then person 1 should also trust person 6. But it is not satisfying. It is contradicting. That means we have at most only one town judge if all the two conditions is satisfying. At most one judge. So how we can solve this question? Also, it is given you are given an array trust where trust I equal to AI BI. That means you will be given an array of trust and where each trust indicates A, comma B, where A trusts B. So using this information, we have to identify whether there exists any town judge in, in the town or not. If there exists a town judge, we have to return the label number of that person, else we have to return -1. So let's take an example. Suppose we have n equal to 4%. And the trust vector says like 1 trust 2, 2 trust 3, 3 trust 4, 1 trust 4, and 2 trust 4. That means we have 4%. So in the beginning, can we say all the 4 persons are the candidate to be a town judge? That means 1, 2, 3, and 4. All the 4 persons are the candidates to be a town judge. Now let's see whether for condition 1. So given this information, first we will try to map the, the trust person for each person. That is, we will try to map how many person to how many person people 1 trust, how many person 2 trust, how many person 3 trust, and how many person 4 trust. Suppose it is given 1 trust 2. That means 1 trust 2. We will map 2 with 1. 2 trust 3. That means we will map 3 with 2. 3 trust 4. That means we will map 4 with 3. 1 trust 4. We will map 4 with 1. And 2 trust 4. That means we will map 4 with 2. Now, since the condition is saying the town judge trusts nobody, so by looking at this map, initially we can say once person one is trusting anyone, that means person one is out of the candidate. Since person two also is also trusting someone, that means person two cannot be a candidate. Now, since person three is also trusting someone, person three also cannot be a candidate. So we are left with only one candidate. Right. Now we will see whether condition 2 is satisfying for this candidate or not. That is person number 4. So what is condition 2? Everybody except for the town judge trusts the town judge. So we will see whether 1 trust 4, yes, 1 trust 4, 2 trust 4, 3 also trust 4. That means remaining person is trusting person number 4. That means 4 is a town judge. 4 is a town judge. So in this way, we can identify. So what we have done here? So we have mapped the persons whom we are trusting. Like we have mapped person number 2 and person number 4 since person number 1 is trusting. And a person can trust more than one people. So that means it will be s- either a set or vector, something like that. If we define a data structure. So once we will insert all these trusts from this given vector and we will map by during mapping only we can identify whether that person will be a candidate or not. So suppose once we found that one is trusting someone, that means one can never be a candidate. So at that time only we can remove one from the candidate list. Let's see one more example. Suppose we have n equal to 3 and 1 trust 2, 1 trust 3. That's it. That means initially the candidate list contain 1, 2, 3. Right? Now we will map the trust for each person. Since 1 trust 2, so now only we can say there and there that 1 cannot be a candidate. So 1 is out of this candidate list. 1 trust 3. So 3 is also, 1 is also, again 1 is also out. So we have already marked. Now we will see how many persons are remaining for the candidate. So 2 persons, 2 persons are remaining for a candidate list to be a town judge. Now, since we can see point number 3 says there is exactly one person that satisfies property 1 and 2. That means no two-person can be a town judge. So, there and there we can say, like in the town, no town judge exists. So, we don't have to check the further conditions because the candidate will always be one. There cannot be more than one candidate. So, if we see point number 2, everybody accepts the town judge, trusts the town judge. That means 2 must trust. If 2 is a judge, town judge, then 2 must trust 3 and 1. If 2 is a town judge, that means the remaining person, that is 3, that means if 2 is a town judge, that means 3 must have been trusting 2. Then only we can say like remaining person is trusting 2. Or if 3 is a town judge, then we can then 2 must be trusting 3. Then only we can say 1 and 2 are trusting 3. But the trust list of 2 and 3 was empty. So we can say like there don't exist any town judge. So once we insert this trust in a map and we check the first condition, and if there still exist more than one candidate in the list, that means there cannot be a town judge. And if there exists exactly one candidate, then that means there is still a possibility that that person is a town judge. Exactly one person is a town judge. So after that, we can check for each of the person except the town judge whether that person trust that the candidate or not. So to create this map, we have two options. Since we can have more than one numbers in a map value, so we have two options. Either we can take a vector or a set. Let's see the options. Suppose we are creating a map like 1, 2, 3 for each number for each person. Now we can take either vector or a set. Since we are not worried about the arrangement of this trust, so we can take an unordered set. And and for vector, we can take either a variable size vector or a fixed size vector. If we are taking a fixed size vector, then it must be n. That means for 1, if the total n value is 4, then we must create a vector of size 4. And once we see that 1 is trusting 4, we can mark that cell as 1, else initially it will be 0. Now, if we see 1 is trusting 1, 1 is trusting 2, then we can mark this cell as 1, like this way. Or if it is a variable size, then if we see 1 is trusting 2, in that case, we will take a vector and we will push 2 in the vector, like this way. So it will be a variable. So if we take a variable size vector, then the whole size of the map will be big O of the total number of trust we have. If we are taking a fixed size vector, then the size of the map will be n cross n, that is n square, right? And if we are taking an unordered set, so we can we have to take a variable size, and in this case also the size of the set will be O of crust size. Now this was the size of the vector. Now we will see what will be the time complexity if we search in a variable size vector, fixed size vector, or in an unordered set. So performing, after mapping the crust in the map, that means we have already checked condition one. And after checking the condition one, if we are left with only one candidate, then we have to do a further check. Else, there we can say that we don't have any town judge then and there. Now, if we have one candidate, then except that candidate, we have to check for the remaining person whether that person is trusting this candidate or not. So if we check in a variable size vector, it will, for each person, it will take a trust time, the size of this vector time. That means in overall, it will take big O of trust time, right? And if we have a fixed vector of size n cross n and we have a map, then we can directly check for that candidate location. Suppose this is the candidate location, whether the value is set or not. So for this, we can check in big O of n time, right? For each person, we can check in big O of n time. For each person, we can check in O1 time. For each person, we can check in O1 time. And for all the persons, it will take big O of n time. Similarly, in a set vector, if we take unordered set, in this also we can check in big O of 1 time. So, as we know, in unordered set, we can directly check any value, whether it exists or not, in O1 time. That means in variable size, if the size of the map is less, then the time complexity to search will be greater. That is, if the time complexity to search will be greater, since it is taking O of trust time. And if the size of the vector is fixed, then in that case, we have to trade off with the size of the vector, since it is taking O of n squared time, n square space. So let's draw a chart and see which data structure will help us. So if we are creating a map, so we have three options: either fixed vector, or variable vector, or an unordered set. So in this space complexity, we see fixed vector will take n cross n space, and variable vector will take the space equivalent to the trust size, and in unordered set also it will take equivalent to trust size. And we can say, and trust can never be greater than n square. So n square is always greater than trust. So this was about space complexity. Now, if we see about time complexity to search whether that candidate is present or not. So in a fixed vector, it will take big, for each person, it will take O of 1 time, and for n person, it will take O of n time. And in variable size vector, for each person, it will take O of crust of that person size, O of trust for that person, and in overall, it will take big O of trust time. And in unordered set, it will take for each person, it will take big O of one time, and for in overall, it will take big O of n time. That means it is very, from this we can say like it is beneficial if we create a map of an unordered set, because taking this will give us efficient space and efficient time complexity to search. Let's try to code. First, we will create an unordered set which will indicate the list of candidates. So let's suppose this is the, let's name it with nobody. Trust nobody. So these are the candidates to be a town judge. So let's insert the element inside this. I equal to 1 to I equal to n, I plus plus. Trust nobody dot insert I. Now we will create a map, and we have decided we will take unordered set as it is giving us the space and time complexity efficient. So trust vector inside this, it will be, we have n elements, unordered set, n plus 1. Now we will iterate the given trust one by one, and we will insert in this map. So trust vector of it 0 dot insert it 1. That means I this person trusts this person. And since this person is trusting any of the person, we will remove this person from the candidate vector. So from the candidate trust nobody, we will remove that person. Trust nobody dot erase it of 0. Now after mapping, if we can see whether we have, whether we will check how many candidates are present in this trust nobody. If trust nobody dot size is greater than, is not equal to 1, that means we cannot satisfy condition 1 and 2 for all the candidates. That means in that case we will return -1. Else else we can say like the candidate, like possibility of a candidate judge candidate is equal to like trust nobody dot bacon, that first element. So this variable we contain only one element, which is the possibility of a town judge. So now we will see whether this person is being trusted by all the remaining persons in the town. So for that, we will start iterating from I equal to 1 to I equal to n I plus plus. And if I is equal to same person, judge can't, then we will continue. Else, please check if from the trust vector of I, we will check whether that person I is trusting this candidate or not. If it is not trusting, that means there exists one person who is not trusting this candidate, which is violating point number two. Since in point number two it was saying everybody except the town judge should trust. Now we have seen that this person is not trusting this candidate. That means in this case we will return -1. That means there not exist any of the person as a town judge. Else we will return this judge, this person as a candidate. So let's check trust nobody. We have inserted all the candidates. Now we will create a map here. And in this map, trust in this map, we are inserting each trust. And if I2, IT0 is trusting any of the person, that means IT0 cannot be a candidate. And if trust nobody dot size is not equal to 1, that means either there is 0 candidate left in this nobody set, or there is more than one person, which violates this condition 3. In that case also we will return -1 if there exists any of the person as a judge after doing the mapping. That means that can be a possible candidate, and for that we are checking one by one whether everyone trusts that person or not. If everyone trusts that person, that means that is the candidate. Let's try to submit the test cases. Okay, trust vector spelling is wrong. And let's try to submit. Yeah, now we can see the solution is accepted. So let's analyze the time complexity for this solution. So here, so in this, we are inserting all the members as a candidate. That means it is taking big O of n time. In this, we are mapping all the trust. It will take big O of trust time. And the maximum possibility of this trust can be n square. And in this will take O1 time since it's a simple operation. And in this is running O of n times, and inside which we are performing a find operation which takes big O of 1 time in case of unordered set. So overall time complexity is big O of trust plus n. So whichever is maximum. So If the trust size is maximum, then the time complexity will be trust. If n is maximum, then the time complexity for this algorithm will be n. Meet you in the next video. Thank you.